Hello everyone and welcome to this video on secure coding practices for authentication. In this segment we'll explore the importance of robust authentication mechanisms and discuss best practices to enhance the security of your applications. Authentication is the process of verifying the identity of users before granting them access to protected resources. It plays a critical role in securing user accounts and sensitive information. Let's take a look at some code examples to illustrate secure authentication practices. It all starts with properly implementing the login functionality. First, it's essential to securely store passwords. Instead of storing them in plain text, which you obviously don't do, use a strong hashing algorithm such as bcrypt to hash and salt the passwords. Salting the passwords adds an additional layer of security by appending a unique and random value to each password before hashing. This makes it more challenging for attackers to crack the passwords even if the hash is compromised. If you want to know more, I encourage you to watch my video on password hashing. In that video I go into detail on how to perform hashing, how to apply the salt, and so on. When users create accounts, enforce strong password policies. Encourage the use of complex passwords containing a mix of uppercase and lowercase letters, numbers, and special characters. Do not force them to change their passwords just because 3 months passed or something like that. So if you force users to change their passwords periodically, then you will end up with lots of bad passwords. What you should do is you should force them to change their password if their password appears in a leak or they appear in a password file. Then you should force them to change their passwords, which you should always check. Obviously, you don't have access to the passwords, you only have access to the hashes. But if the hashes get leaked for some kind of reason, you should definitely enforce a change of password, but don't do it unnecessarily. Also implement server-side password complexity validation to ensure users adhere to these requirements. Let's see how they work. I will use the username as a password to demonstrate the effect because otherwise you wouldn't be able to see the password. So you can see here, I use a couple of passwords that are either too short and don't use all the required complexity requirements we went through. And you can see that finally I can get to a password that actually works. Additionally, you can consider implementing mechanisms like a real-time password strength meter to provide, real-time feedback to the users whether the password is secure or not. And this helps with the frustration factor. If your password gets rejected for the 5th time, it's easier to have this being displayed at runtime. To protect against common attacks such as brute forcing and timing attacks, implement account lockouts and rate limiting. These mechanisms can prevent malicious actors from repeatedly attempting to guess passwords or exploit vulnerabilities. So you can see here a pseudocode basically with some actual PHP in it. This is basically how you would implement it. You just count the failed attempts, and after a certain amount of times you just lock the account, and you can do this by basically resetting the password on the database and telling them, you need to reset your password, but you need to kind of like override the password that's in the database file once the account is locked out. Also, when handling user credentials, remember to sanitize and validate input to prevent any potential injection attacks, which we have seen in a previous video. Use prepared statements or parameterized queries when interacting with databases to prevent SQL injections. And you can check out my video on input validation if you'd like to know more. Finally, consider implementing Multi-Factor Authentication or MFA to add an extra layer of security. MFA combines something the user knows, like a password, with something they possess, like a security token. And it could also be like a biometric factor, but we'll now discuss the possession aspect of authentication. And I will show you 2 variants of MFA. First, you can see here a user that wants to log in. As our code snippet from before, the web server now prompts him for the second factor. This factor is usually triggered by timing events, meaning this number changes every 30 seconds or so. It is important that clocks are synchronized, so between the device and the server, because otherwise the server doesn't know which code is valid at a given time. So anyway, the user reads the second factor, enters it at the login screen, and is granted access. The second variant is more common today. Instead of a code which the user has to enter, the server sends the request to the user's device, which prompts a push notification, which the user has to accept. That way it's made sure that additionally to the password, the person trying to log in is also in possession of the registered device. Both variants are pretty secure. The push notification doesn't require the user to panically enter a code that changes every 30 seconds and is therefore preferred. By following these best practices, you can significantly enhance the security of your authentication mechanisms and protect your users' accounts from unauthorized access. Remember, secure authentication is a critical concept of secure coding. By implementing all the methods we've seen in this video, you can create robust and resilient authentication systems. Thank you very much for watching this video on secure coding practices for authentication. Stay tuned for more security and privacy related content, more videos on secure coding, and the like. Don't forget to like, share, and subscribe to the channel for future updates. Until next time, stay secure.